Today we're going to start with a topic matter called chi-squared testing. Chi-squared is written like that, and chi-squared is another probability distribution like the Z or T, and we can do several interesting tests involving that, and of course we can do many more than what we'll cover here. We will cover two different kinds of chi-squared testing. One is called the goodness of fit. This test tests how well an observed distribution, probability distribution, fits, hence goodness of fit, or follows a hypothesized probability distribution. Null hypothesis will be, in a sense, that the observed distribution is equal to the given distribution. This test is a generalization of the one sample two-tail test on proportions. In such a test we had, and we didn't look at it that closely, but we had two categories, heads and tails. And we might want to know if the probability of getting a head is a half, but we could have looked at it in terms of the complement. Is the probability of a tail also a half? So we had two categories in such a simple test. In a goodness of fit, we can have as many categories as we need, more than two. We don't need to go some event and its complement. The next test, which turns out to be more interesting in practice, is a contingency table test. And this test tests if two qualitative variables are related. Right? For instance, are smoking and lung cancer related? Those are qualitative variables, and we could answer the question if those things are properly measured. This test is a generalization of the two-sample two-tail test on proportions. Probably will become clearer as we look at problems, but just as the first was a one sample test, we had two categories with one sample against a fixed number. Now we have two samples against each other. What we can have in a contingency table test is not just two samples and two categories, and so have a two-way table with 2 by 2, we can have as many subsamples and as many categories in the probability distribution as we want. But as I said, this will become clearer as we do the problem. Let's now have a look at a chi-square distribution. This is a chi-square distribution with 1 degree of freedom. It's hard to see what's happening here, so let's increase the degrees of freedom just a little bit. That's 2, 3, 4, 5, 6. Alright, and then you'll see essentially what a chi-square distribution looks like. It starts off quickly and then trails off to infinity. And is of less interest to us right now, but as the degrees of freedom get large, that distribution starts to become approximately normal. But most of our tests will be for smaller degrees of freedom. Alright, so it starts off at 0. There's no values for the chi-squared less than 0. It starts off quickly and then it trails off to infinity. So chi-square distribution table looks sort of like a t-table. Down the side we have degrees of freedom, 1, 2, 3, etc. And we'll only use small degrees of freedom to make our calculations simpler. And across the top we have a chi-squared with, say, 10 degrees of alpha of 10%, chi-squared with alpha of 5%, and a chi-squared with an alpha of 1%. Alright, other than that, we need to look at these two tests one by one. So this is the end of the introduction.